All right, this video is going to cover special product factoring, and this actually is the reverse concept of 7.3. So 7.7 is going to be a reverse logic of what we've already done. So what we're going to do here is talk about square roots again. So let's talk a little bit about rationalizing things before we go further. Now, let's talk about square roots. So if you recall, when we did chapter 6 and then a little chapter 9, we talked about square roots. So take out your calculator and let's do the square root of 49. Okay, square root of 49, it tells you is 7, but you need to realize that since it's a square root, the possibility of it being negative is also true, because plus or minus squared is going to make it a positive regardless. So when we talk about this section, keep in mind that you're going to have one positive and one negative. Now, rewriting them is going to be very important. When we do this, keep in mind that you're going to have two groupings for the first part of this and one grouping for the second part of it. So let's do the first part. The first part is called difference of squares. So as you can see, this is going to follow the same line, same type of titling as 7.3. The only difference is that I'm going to give you the answer and you have to work backwards. So don't fret. Let's look at number 1. We're going to have s squared minus 49. Now, like I showed you up here with the square roots, you're basically square rooting them. So there is no extra work to this. It's just a puzzle. Okay, so we break down the two groupings. So you ask yourself, the square root of s squared, we know, we've talked about this over and over again, is just s. So we put s in front of both of them. Now this is difference. I don't know how many little stars I can put here. Difference means that one positive and one negative. We get that because of the square root. So the square root of 49, we already found at the beginning, is going to be 7. So your answer is just s plus 7 and s minus 7. That's it. No further needs to be taken there. So when you're doing these, it takes longer to explain it than to actually do it. So let's look at number 2. T squared minus 81. So I want you to pause the video and I want you to try to do this one. It is very similar to what we did for number 1. Okay, hopefully you've paused the video and you are ready. So once again, we break down our two groupings. We know that the square root of t squared is just splitting it in half, which is going to be t in each one. Remember, it's a difference of squares, so one positive, one negative. And the square root of 8 is plus or minus 9, so 9 and 9. And that's it, folks. So let's talk about what if I have numbers in front, what if they flip them around? Well, you're going to treat them the same. You're just going to have to be very cautious about how you set them up. So if you look at number 3, we have 16 minus x squared. Now, folks, there is nothing difficult about this problem. You are still doing the same thing. The only difference is instead of the 16 having the plus and minus in front of it, it's going to be your x. That's the total difference with this. So if I take and break this down, we still have to do the square root of 16, which if you do the square root of 16, we're going to end up with 4. The negative and positive sign are going to be carried by the x this time. So yeah, you could put the negative there, but you're going to find that it just undoes itself. So we just leave it off the 4s and let the x carry the signs this time. So once again, the square root of x squared is just x. And that's it, folks. We leave it written like that. So now try number 6, because it's the closest one we have that is similar to this. Don't panic about the number in front of the k squared. Remember, just square root it like you've been doing. So take a moment and try this one, and then we'll check it. Okay, hopefully you've paused it and you've had a moment. So just like before, we square root the numbers. So the square root of 81 is 9. Remember, the variable is going to carry the sign, so one positive, one negative. Now, the only difference between this one and number 3 is that you have to square root the 49 first before you can split the exponent in half, which is going to make it 7k and 9 minus 7k. And that's it for these. So now you're ready to do number 4 and number 5 on your own. We will check those later on in class, or you can send me an email and ask. All right, so the pattern thing I'm not worried about. I want to go into 7.3. I'm sorry, 7.7, the second half of that, which is number 13. Apologize for that. We are treating this the same. These are perfect squares. Squares. Sorry, my spelling and I are not working at 10:30 at night. So perfect squares basically say this. Instead of having a binomial they're giving you, they're going to give you a trinomial. However, you are still using the exponent thing. Here's the thing. This is something that you need to understand. If you don't see the perfect squares, you can still use the x factor. But let me show you what you discover every time you use the x factor. These are easy to do the x factor. So yes, it's a positive 16. Yes, it's a positive 64. We just did this one. It's positive 8, positive 8. So you know your answer is x plus 8 and x plus 8. If they are exactly the same, then you write it as quantity squared, x plus 8 quantity squared. However, these are easy to do, you have no problems, but let's look at something like number 17. So number 17 is where the rubber hits the road. You are not going to be able to do the x factor or umbrella method that we used before because they are very large numbers, and this has such a simple way of doing it. So let's look at the simple way, because I know that you guys like to try it on your own with other things, which is great, but sometimes you just need a shove in the right direction. So in this one, I'm going to give you a shove in the right direction. We have 36c squared plus 84c plus 49. So the first thing you're going to notice, look at these numbers on the ends. The numbers on the ends tell a story. They tell you that they can be square rooted. They also tell you that they're both positive. So they have to do two things. They have to be positive and they have to be located on the ends. So if they're not located on the ends, and the other thing is you always remember, it has to be from descending power order, so biggest exponent down to no exponent. So that means that if it's not in that order, you need to rewrite it before you make any of these type of checks. Otherwise, it's a moot point and you have to start over again. So we'll say for argument's sake, we have it in the right order, which we do. We check and go, oh, look, they're both positive. Not everything, but the first and third terms are the ones that have to be positive. And they have to be located on the ends. Okay, so the numbers have to be on the ends or this doesn't work. If this is all true, then you literally go just like this. Don't worry about the 84. I'll explain where the 84 comes into play in a moment. The square root of 36 we know is 6, so we put a 6 in each one. We cut the c squared in half and put c in each one. Look to the middle. The middle is used for two purposes: to get the signs for both groupings, and it's your check step. So for right now, let's just use the sign part. We have to plus because 84 is positive. The square root of 49 is 7. Now, what is the check I'm talking about? Well, remember when we did the FOIL method, that OI. So if I multiply 6 times 7, I get 42C. And if I multiply 7 times 6, I get another 42C. Well, 42 plus 42 makes 84. So therefore, if the OI, so OI check is correct, then we're able to go into this. So my final answer is 6C plus 7 quantity squared. All right. So what I want you to do is try to do the others. There's only a couple of those. Number 18 is the last one. The fractional part we'll talk about in a second. So let's stop here and then we'll pick up in part 2 video of special product factoring.